Thank you very much, and a very warm welcome to NXP here in Korea. I'm actually delighted and I'm very glad to see so many of you being interested in our company. NXP has today a very special day because we have our 10th anniversary today. So it is exactly today, 10 years ago, that the company NXP was founded. Our heritage, however, is much, much longer. You know that NXP originated out of Philips Semiconductors. And during the last 10 years, we have very, very much changed the company. But we have not only changed the company, we have also shaped the industry through leadership, thought leadership, product leadership, and market leadership in a couple of specific domains. Certainly in the security domain, NXP is a leader in security for payment, for government identification, also in mobile, and certainly in automotive. And I will speak a lot more about automotive in the next half hour or so. But we have also grown the company organically and unorganically. So you certainly have all seen that in December last year, we completed the merge with Freescale Semiconductor, which was a very, very strong move in a consolidating semiconductor industry. And through that move, we have become the #1 semiconductor supplier to the automotive industry. So by today, NXP is the largest chip company serving the automotive market. And if you go to the next slide, Lars, then maybe this is the best way to show what we do here today. This is a 7 Series BMW, which is the latest model. It's an award-winning model, actually, which you can go and buy today. So this is all available. It's not about the future. This is today. And NXP has in this car more than $300 of semiconductors, chips, in the applications which are shown here. Now, we are not only very strong in this car, but we are the #1 semiconductor company in car infotainment. We are #1 in body applications. We are #1 in powertrain. We are #1 in the secure car access. And we are #1 and growing very fast in the new domains of ADAS, safety and security, which is the future of automotive. Automotive will change a lot. But this is where we are today, market leader in automotive semiconductors. Next slide. Let me give you a little bit more detail on how this shapes up. The automotive semiconductor market is $30 billion. So the global market for semiconductors in automotive, $30 billion. A quarter of the market is in microcontrollers, a big quarter in analog, a smaller piece in sensors, and then you have some other parts. We have the technology capability to do all of this. We can do everything in microcontrollers. We can do everything in analog and RF. And we can do a very big part of the sensors. And we leverage that technology position to be a solution leader in these applications. So these are the applications in which we are a solution leader based on the technology breadth which we have. And I said it before, car infotainment, secure car access, body, safety and powertrain, we are #1. Now, that #1 position in solutions translates this in the overall market position. So this is the overall market. We have 14% market share. NXP, #1 in automotive semiconductors with 14% share. The next largest player is Infineon, Renesas, ST Microelectronics, and Texas Instruments. And you see that we are 1.4 times bigger than the next one. So we have 14%, the next one 10%, again 10%, 8%, and so forth. The message is we are a very strong leader, but we still have a lot of room to grow. So we clearly see that with 14% share, we are big, but there is much more we can grow. So we clearly want to drive this harder. So the rest of our presentation today will be all about how are we shaping, leading the future to grow our market share in what is a very, very exciting market. Now let me talk a little bit about the market. We think that the automotive industry will change in the next few years significantly more than it has changed in the past 50 years. And the main changes will come from cars becoming connected with the environment, from cars becoming electric, and from cars becoming so much more convenient to use. Because we as users, we want to have a car which is just much more sexy and much more fun to drive. Now, most of this is driven by the demand for more safety, by the demand for less CO2 emissions, so environmental concerns, and thirdly, simply by the consumer demand for something which is more fun, more sexy. I mean, if you think about, somewhere is my smartphone. If you think about a smartphone, it's always becoming more sexy, every generation. The same with the car. But the car has two more elements. It should be more safe, and it should bring down the CO2 emissions. So the future of automotive is driven by these three trends: safer, cleaner, and more fun to drive. All of three are enabled by electronics. And that's why we are so excited about this market, because all the innovation, 90% to be fair, is enabled by electronics. So everything I was talking about, this whole wonderful new world, is all about electronics. So we as a semiconductor leader in this industry is, of course, in a fantastic position. Now, Lars, if you go to the next slide, let me put it a little bit more dramatic. I talked about safety. What I need to say is that, unfortunately, globally, 1.3 million people are killed in traffic accidents every year, which is a big number, and which is, I think it's a very sad number. 1.3 million killed in traffic accidents. Research, and the detail doesn't matter, but research shows that from this 1.3 million people which are killed, more than 90% of the reason is human error. So it's people who make a mistake when they drive. And the mistakes are, people are tired, or you look to the backseat to your kids and you are distracted from driving. Maybe we have drunk a little bit too much alcohol. But there is a lot of reasons why people just don't pay attention, and that's why it comes to traffic accidents. And that's the whole idea. While I think the biggest change in the future of the automotive industry is about cars which we call in future self-driving robots. So a car which is replacing the human being when it comes to the driving task. This is a very simple way to show how we think about that. What we want to make sure is that the car starts to do what we human beings are doing. It has to sense its environment. So it gets information about other cars, it gets information about pedestrians, about the traffic light, is it green or is it red? So that's sensing the environment. With all of that information, it starts to think, which means the car, like our human brain, will take decisions on what to do, on braking, on accelerating, on steering. And then it needs to take that decision and put it into action, which is actually indeed accelerate or brake or steer left or steer right. Everything I described now this whole chain is currently happening in our brain and with our muscles, in the steering wheel and with the brake pedal. Now, the whole idea is that NXP, together with software companies, we will translate this into electronics. We want the car to take all of these tasks. The car will sense its environment with a multitude of different sensors, radar sensors, cameras, maybe LiDAR sensors. The car will talk to other cars. It will be connected with other cars and getting more information. There will be very powerful processors in the car which will take the brain work. They will take the decisions. They will fuse the information from all of these sensors and will decide what to do. And then there is again electronics through a network in the car which will make sure that all of the intelligent decisions are going to the brakes or to the steering, etc. So this is a big paradigm shift because it really takes the human being out of the equation, making the car much safer. Now, it's not only about safety, it's also about convenience. If I think about the long stretches on a highway, it's just more convenient. You could sit in your car and play cards or read a book or do your email instead of driving. And it will bring congestion down because if in a city like Seoul, if all the cars were like this, we wouldn't have traffic jams because these cars would be much better organized. So there is a lot of advantages of doing this, and that's why the industry is strongly, strongly pushing in that direction. Now, let's look a little bit closer in how to do it. Lars, if you go here. Now, this looks big. Actually, what is on the slide is that small. This is a very important piece in the sensing side of the self-driving car. It is the smallest radar sensor in the world, which is very, very relevant because there will not be just one of these sensors in the car, but a multitude of sensors. So all around the car, we will have these radar sensors which take information from the environment. And since they are so small now, we can mount them in mirrors and in very small places in the car where you don't see them. Behind the steel, they measure through the steel, and such a radar sensor coupled with 10 others or 12 others provides a perfect digital image of the surrounding of the car. It can also see through fog, which we couldn't do with our human eyes. It can see in the night, so it doesn't need daylight. It can, in the night, it perfectly sees. Now, this concept is a very nice example of the innovation power of NXP after the merge with Freescale, because the processing side comes from Freescale. The transceiver in 77 gigahertz, so that's a very, very high frequency, comes from NXP. And we are the first ever company who has put this into CMOS processing technology. That is very relevant because going forward we can make it even smaller. We are now very busy putting these two pieces into one piece and making it even smaller. But also all the analog circuitry, like the voltage regulators, the power management, Ethernet or CAN network connections is all from NXP. So this is a very nice showcase how NXP can power a complete solution. So the back side, which is all of these chips, as well as the front side, which is the two radar chips, the whole application is powered by NXP silicon. There is no other company in the world which has the capability to do all of this. Now, it is in heavy use. So you see here that Google is actually field testing this in this little robot car. But also from the more traditional car companies, Hella, which is a very successful German tier 1 supplier, they also put all of their radar innovation on this concept. I think Hella also has a JV here, right? Mando
is one of the big users,
which is pretty well known. So this is just one example of how NXP is innovating and leading the innovation in the sensing side of the self-driving car. Now, next slide. We want to make the car more safe, more intelligent, and faster in its reaction time than we human beings are. And the real breakthrough in our mind is what we call V2X. So that stands for vehicle to vehicle or vehicle to infrastructure. So that's the communication between your car and other cars, or your car and the infrastructure, which is a very, very powerful tool, because through this communication, you can make the car see around corners, or you can make the car see through trucks. So the car will have a capability which we as human beings just don't have. So examples are like here. This is a building, so the car could see that around the corner is a traffic jam or a construction site, because this is communicating with the car, electronic communication, and that's very fast. The same thing here, you are behind the truck, you know the situation, you see only the truck, you don't know if there is other cars behind or if any coming in your direction. Through communication between all of them, in real time, you get a very, very powerful information in your car. It's actually very powerful because the distance of communication is very long, so it's like 1.5 miles. So if you are driving in your car, you get all of the information of all of the cars in 1.5 miles circle around you, which makes it a very powerful set of information. We will have this concept with the Korean Olympic Games. So we feel very privileged and very proud. So when the Olympic Games take place here, there will be big field trials and they will be equipped with our concept. Now that's a little bit out still, but already very soon, which is next year, this system is also going to be used by General Motors, the very big US car company. They will have this in their Cadillac next year, which is launched as a new car. So this is not something just for the future. It is actually on the road next year with the new Cadillac from General Motors. Now, if you go to the next slide, Lars, there is another use case of this, which is extremely powerful. And it is called truck platooning. So this technology is being used in digitally, electronically connecting trucks one to another. The idea is you can have trucks drive on a highway with a very short distance, and essentially you only need a driver in the first truck, because the other trucks which are following are steered by the first truck. They all communicate, and when that one brakes, this one, but also all the other ones, they know immediately that he brakes. The concept also has a camera and also has radar. Now, you see this is a photo. This is not just an idea. So we have had a large field trial with this last year in Europe with 6 truck companies. One of them is DAF. And there is a little movie here which maybe shows you much better than I can explain how that really works. So Lars is going to start this video now. To see the idea of how to digitally, electronically connect trucks.
The platooning challenge is a wonderful opportunity for us to demonstrate this new technology. I would even say that it has exceeded our initial expectations. What we can demonstrate matches or probably even outperforms of some of what our competitors do.
So he's not on the steering wheel, it's automatic. So why does this matter so much? It matters for the logistics industry because not so far from now, we clearly see that we can replace drivers by machines. So like the driving times, I guess also in Korea, truck drivers are only allowed to drive for a certain number of hours and then they have to sleep or rest. That's all across the world, and with this technology, you don't need this anymore. It just works so much safer. Also, the fuel consumption is getting much better because this second truck would be in the windshield of the first one, which saves 20%, I think they found out, 20% fuel. So there's a lot of economic advantages from an electronic innovation which we put into these trucks. Another great example on how NXP is actually powering the new age of automotive. Now, I also talked about the brain. So I said there is all of this sensing, but in the end, something needs to take decisions. And this is where NXP has put forward what we call Blue Box, which is a development platform which does bring together all of the elements for self-driving cars. So it has inputs for all of the sensors. It has inputs for cameras. It has inputs for radar and for LiDAR. It has inputs for V2X. And then in here, you have two strong processors. There is a very high-performance computing machine in here, which we reuse from our networking division, digital networking inside NXP, which does all of the number crunching. It's a lot of performance which is being required to calculate all of the information which is coming in. But there is also a safety controller in here, which kind of, I would say, controls and watchdogs the number crunching machine all the time to make sure this is a safe operation. Now, I say this for a reason, because everybody of you who maybe plays video games or who does something on a PC-like product, once in a while they hang up and they just stop and you have to reboot or do something. This may never happen in a car. The central brain in the car, the central platform, may never stop working. It cannot be it locks up, because if it locks up, your car is just out of operation. And I think that is a scenario which we cannot have. That's why it is so important to have an architecture here which has high compute power, but which has also safety and redundancy mechanisms to deal with the safety requirements in a car. This is where NXP is in a fantastic position. Think about our leadership in safety electronics. We've done this in braking electronics, in electronic steering, in airbags for many, many years. So we know how to handle safety in a car, and that's what we brought in here. Yep. Now, my last point is something which we believe is foundational to the upcoming connected car. It is the cybersecurity requirements. With the car being connected so much more, just look at this, and I guess you all recognize this. You are connecting your car to your smartphone via maybe Bluetooth. You are connecting your car to a wireless key. I just talked about the connection to other cars, to infrastructure, to the cloud. So the car has a growing number of wireless interfaces, radio interfaces to the outside world. And each of them is a potential threat to hacking. So there is a huge discussion in the industry about how can we protect privacy, unauthorized access, and maintain the safety requirements while the car is so much connected. Now, NXP, as I mentioned in the very beginning, is the leader in hardware-based security. In payment, so in your credit cards, it's a high likelihood you have our chips. We moved this forward to mobile payments, so most of the mobile payment schemes in mobile phones is secured by NXP. And also the electronic government IDs are secured by NXP technology. Now we leverage that technology and move it into the car. Now, it's more complicated than just leveraging it. What you find here is a 4-layer security concept which we are pushing into the automotive industry. So we've really enforced this at the moment. Which has 4 steps. So we are securing the wireless interfaces to the outside world. So that's like the door to your house. You lock your door of the house. That's the wireless interfaces in the car. They are like doors. So we secure them. Inside the car, there is a big network. You have all heard about CAN bus in the car, or FlexRay, or Ethernet. These bus systems typically merge in one large processor. That processor has to be firewalled and has to be secured. I say this with a lot of seriousness because those first two measures, this one and that one, were not in place in the chip which was hacked last year. You remember the communication which went across the world, where I think it was Charlie Miller hacked a car from Jeep, from Chrysler. There was, through the infotainment system, through the wireless interface of the infotainment system, no security. And also inside that car, no security in the gateway, so they could get into the brakes and into window lifts, I think, and stuff. So these first two measures are super critical. We have the solutions for that. We are shipping this as we speak, and we are shipping this to the automotive industry. So going forward, I have a lot of trust that cars will become much more secure because we do this already. Now, we thought it a little bit further, and this is technically more complex, but we also secure the network branches. So inside the car, you have then this CAN bus, which is reaching from the gateway to the applications. We are also securing the physical layer chips on the applications. And last but not least, we also go into the processors of the applications. So think about a microcontroller which is sitting in the brake of your car. Even there, we are now applying security. That sounds big. It sounds like, wow, 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 so much effort. Trust me, it really makes sense. This is the only way to make sure that cars of the future will deliver on the promise which we are having, which is very connected, but at the same time cyber secured. So this is a massive discussion. It's a massive endeavor. We think the solutions are not that complicated. We have them, but we work now with the industry to make sure that this is quickly being adopted going forward. So as a last news point here, Lars and we just came from China the other day and worked there with two companies and announced that we inaugurated a common interest group for automotive cybersecurity in China, which will make sure that we establish standards with the government on the right levels of security for automotive. And that falls into the cluster of what we do is not just work with our customers, but we think for self-driving cars, for security, it is about good collaboration between the industry, us, but also politics, and also the public. And here is just a couple of examples. I mentioned the Korean deployment for V2X, which I can't wait for the moment we come back here and see this here on the road. It will be quite exciting. This is Lars, who will speak to you in a minute, my CTO, who discusses with a leader in hacking, I would say. That's Andy, right? Andy Greenberg, who is really one of the best guys in hacking, a white hat hacker, as we say, so with positive intent. But you see, we try to connect to these people to learn what we have to do in terms of security. And the same on the other side. This is the Secretary for Transportation of the United States, Anthony Fox, who has just published a significant guideline for the rollout of self-driving cars in the United States of America. He will also work on a mandate for V2X systems. So this is just to show you a little bit, and there is many more examples on how we try to work not only in the industry, but also with politics and public on something which we consider has the potential to change the world, which is connected, secure, self-driving cars. Which brings me to the handover point to Lars. So thanks at this point, and Lars, take it from here.
Yeah, thanks a lot. Hello everyone, and 감사합니다 for being here and listening to NXP once more. So it's for me almost like the last time I had been here and a lot of you had been in the room, I promised to give an update on the new things that NXP has in the kitchen that we are cooking. And you have heard Kurt saying that we were just coming out of Shenzhen from one of the biggest NXP developer conferences and customer conferences that we have ever had. The good news is this is in Asia. So for us, the Asian market is getting more and more exciting. There is so many new companies, so much innovation going on. And basically, what you have heard Kurt talking about is how we build self-driving robots. And it is our portfolio in the sensing, thinking, and acting domain. So, what do we do for the eyes and ears of a self-driving robot? How can we work to build the brain of a self-driving robot, which was the blue box mentioning? But what we have not talked a lot about in the last 2 years over the various meetings that a lot of us had together is what is going on in the actuation domain. But believe me, most of the value creation that NXP is doing as of today is in this market here. So what we are calling the smart power market. Sounds a bit less exciting than this sensing market here or the brains of the car, but is highly, highly sophisticated. Not a lot of companies can do that. And NXP, good for us, is mastering this field at the moment. Freescale has done a lot in that area. Old NXP has done a lot. And together, of course, we are very, very proud on having a super strong portfolio, which is basically smart power technologies. And when I was here one year ago, almost a year ago, here we had the first time the announcement for Ethernet silicon from NXP in our in-vehicle networking domain. So what we have is, as NXP, we are the market leader for everything that is an electric interface that is connected to the wiring harness of the car. So the CAN, LIN, FlexRay, and Ethernet interfaces are mainly coming from NXP into the market, into this complex wiring harness and over the various classifications, of course, of data rates and bandwidth that such a modern car needs. Why do we invest so much in that electronics? Well, very simple. Because these networks are exploding. They have exponential growth. It is not anymore like in the old designs of cars 10 years ago that you have 5 or 10 control units that you want to connect with a simple CAN line. No, modern cars as of today, so the premium cars, as Kurt had shown them prior, they have 200 to 250 control units as of today. And of course, it does not work anymore that you just have one long wiring harness and plug everything in. Especially it does not work if you want to make this thing data secure. So what happened in the Jeep hack case was there was such a network, all control units connected to that one network, and the hacker could hack in one place and then could freely move in that network. And this is, of course, a drama if you can move from the telematics unit to the engine management unit. So what we are developing at the moment is much more complex networks. The Ethernet connections, the CAN, LIN, FlexRay connections, and then, of course, we have all the control units as end nodes in these networks, but via domains separated. But here you have either very complex control units in the end, at the end of that tree, or very simple ones. You have very uncritical ones, a window wiper, or you have supercritical ones, your ADAS system, your braking system. And what we are basically developing, and they're a big part of our value creation is every control unit, each of the 250, is built with a microcontroller, so the brain of the control unit, plus some additional electronics around it. Power supplies, switches, CAN connections, and all of that we are combining in chips that we call system basis chips. Sounds a bit unsexy, but is very, very important functionality because otherwise such a control unit will not be connected and will not work. Now the key problem is how do you make these system basis chips super robust, and how do you make sure that under no conditions there is a failure in the power supply, for example, of such an emergency braking assistant or similar electronics. So how do you make sure that the functional safety, and a lot of you have probably heard these words, the ISO 26262, so ASIL compliance, the functional safety of these system basis chips is guaranteed. And we have developed, and we have just yesterday released the press releases to the market we have developed functional safe system basis chips that can drive pretty high powers, so up to 2.5 ampere. And therefore, these chips, together with a microcontroller, are a complete control unit. They can drive, in a lot of cases, complete control units. For example, for tiny radar modules, these type of system basis chips are key. They are built in special technologies that not a lot of people can do in the market. Technologies that are very robust, also dealing with 48 volts in the new board networks and the like. The other thing that is equally interesting and equally important is what happens if we are combining these system basis chips and microcontrollers into one thing. And we have a very strong portfolio there. This is called the MagniV portfolio. So here you see how it is written, MagniV. And MagniV is a microcontroller that is able, for example, to drive very efficiently electric motors. Okay, does not sound very sexy, but the market is great. If you're just looking that on average, every car has 35 electric motors already. And that these electric motors are getting more and more important. So the fuel pumps, oil pumps, HVAC, climate control pumps are replaced. Then this is a very, very, by mechanics replaced against electronics. So then this is a very fast growing market. Furthermore, the requirements are to having noiseless motors, energy efficient motors, and maintenance free motors. And these are the so-called brushless DC motors. And for them, you need sophisticated electronics to control them, to steer them. And this sophisticated electronics is this MagniV platform. Just to give you a bit of a feeling, a premium car has only in the seat, per seat, 15 motors, 15 motors. So count by four seats per car, 60 motors only for the seats. The thing that only NXP can do at the moment is we have silicon that can operate these motors in the seat, but the silicon of the MagniV is so temperature robust that it can also work with oil pumps close to the engine, so in high temperature conditions, which is the good news for the car OEMs, so for the LGs of this world and for the Bosches and Densos, because they are developing their software once to steer an electric motor, yeah, and then regardless of where that motor goes, oil pump, okay, same electronics like seat control, like window lifter, all of that is basically coming from one controller platform at NXP. So we have 27 derivatives, so it's a very big family of these MagniVs to fit every power requirement and infotainment connectivity requirement, sorry. But by and large, of course, a very, very great value proposition for us. And our claim to fame is that we have application-ready code, software tool chains that a normal engine motor steering developer can get production-ready code within 10 minutes, running on our reference designs and operate the motors. And this is, of course, point one for us, of course, a great value proposition, but also for the car developers, a fantastic thing. Using the same technology, you can not only pump energy into motors, but you can pump energy everywhere. For example, here. How about I come into my car, throw my mobile phone on a charge pad. I don't need a special connector anymore, so I have my iPhone. Some of you here for sure have Samsung phones, yeah, and always the connectors don't match. That's simply ugly. Then you have a tablet that does not fit into the docking station. So of course the idea is let's have wireless charging in cars. Let's have wireless charging at home. There is a key standard and a power mat, for example, and these charging standards NXP can support. We have 5-watt solutions where you can basically generate a charging pad in the car. We have won most of the sockets, most of that market in 5 watts already in automotive. But we have enhanced that to 15-watt systems. So if you want to have a fast charging, you just hop at home in the car, drive to the office, your mobile phone is almost empty. Then you don't want to wait for 3 hours on your charge pad till the mobile phone is back to charge. So we have announced yesterday that we are the first in the world who have a 15-watt charger, 15, which is standardized. It's specified already, for example, in the key standard, but no one was delivering this. And especially not under automotive circumstances. The great thing that an NXP now can bring into the market is these systems radiate, was not designed in that way, but by accident. They radiate on the same frequency like car access systems, like car keys. So if you don't do this carefully, if you don't build that carefully into the car, if you don't have the system understanding, then a cheap and easy charge pad will disturb your key and you cannot lock and unlock your car anymore. This is of course not what you want to have. So the good news is NXP is market leader for car access. And this here, you see this tiny little chip here, this little black dot. This is basically the entire car key that you need for a passive keyless entry system. So key goes into my pocket, I go to the car, pull the door handle, car recognizes my key is closed and opens up. This is a very big market that we are supplying. And these systems, of course, must be designed together in a way that the buyer who buys a €100,000 luxury car does not always get compromised. Whenever that thing is charging his mobile phone, the key doesn't work anymore, or the other way around. So we can deliver that to the car OEMs, to the tier ones. And what we have done is, and what we have also announced, using the same technologies, again, energy pumping devices, so to say, is for this little key, the base station in the car. Because the key, of course, is a great piece of electronics, but it's worth nothing if I don't have the good reception electronics in the car. And good reception electronics means the following. You need to exactly determine where this key is. A lot of countries demand by law that you know whether the key is outside of the car, and the two of us, we are chatting outside of the car, or whether the key is inside of the car. Because if the two of us are standing outside of the car and we are talking, the car must not start. Just imagine my kids are in the car and we stand outside and my daughter presses the start-stop button. Then it must be basically disabled. If I have my key in the pocket and I'm standing here close to the chassis of my car must not start. If I have the key in the other pocket and I'm sitting in the driver's seat, so close to the door, to the metal wall of the car again, the car has to start. So it's really, you need multiple antennas determining exactly by the centimeter the position of the key in my pocket. And this piece of electronics is a one chip, we call it LF transceiver, with 6 antennas. And it's basically using similar circuitry also like our very sophisticated amplifiers. But basically, this is the counterpart of all our great key innovations. And just to round off the key innovations, I had mentioned that a few times in the past. The key question is, of course, okay, keys, is there any news? What are you developing into keys? So what are the next innovations coming along in keys? Well, there is 2 topics that NXP is massively driving at the moment. So Freescale brought a very nice portfolio of motion sensors into the family. So we are putting in the meantime on these little key fobs, we are putting a little MEMS sensor, and then the following happens. If someone wants to fake your key, read out your key, and there is certain relay station attacks that can happen, then the key can basically be overheard by someone, and can be overheard by someone who is standing close to your car, and you're bridging a long distance so that a thief could open, in theory, your car. This can only work now if the motion sensor senses that the key is close to a human being. Because the use cases that typically happened was, I go home, throw the key onto the cupboard next to the front door, and the key rests there overnight, and the thief goes from the outside to stimulate my key and open my car. This does not work anymore, because as soon as the key is in rest, we do a very simple thing. We say, hey key, go to sleep and save your battery. So one thing is, with that little MEMS sensor in the key, the battery lifetime goes dramatically up, so we don't have to replace these expensive coin cells all the time. So instead of 2 years of key lifetime, we get 3 or 4 years of key lifetime out of it. And we get super robust against attacks. These relay station attacks are blocked with that. And the other thing is, what we are doing is we are taking ultra-wideband technology, so a high-frequency technology, 5 gigahertz, and with that we can measure very, very accurately where exactly the key is from a 10 meters distance, not only in terms of proximity, so how close is the key to the car, so exactly what is the angle of arrival, so where is this handbag of the car owner, in which position. And what some of the car makers are already doing is they are doing light pointing, so a nice light carpet towards you when you approach your car in your favorite color. So really, really posh use cases, of course, convenience use cases, steering the car as you approach the car, but also, of course, you can use this for steering all other sorts of smart devices. For example, your smart home. You're parking your car, walking out of the car, and you take your key and walk up the walkway to your front door. Why shouldn't your walkway lights switch on as you walk so that a light bulb is accompanying you? Very posh use cases, and you will see them in the cities in the next years, I promise. So this is basically the stuff that we are working on at the moment. Very, very interesting innovations also from the car key side. Yeah, and with that, thanks for listening in. Kamsahamnida, and I think the floor is open for questions. So whatever you have on your mind concerning NXP, please shoot it at Kurt and myself. Thank you.
Thank you.